we are discussing simplification of inverse circular function by substitution method. This is continuation of part 8. So in part 8 we have already discussed problem number 1 and problem number 3. Problem number 2 exactly same that of 1. Then problem number 4. Y equals to cot inverse root over 1 plus x square minus 1. So this is 1 plus x square. So x equals to tan theta or cot theta, you have to put transformation. To remove root, so put x equals to cot theta, or you may put tan theta also. So what is theta? Theta is cot inverse x. Now our main aim is to remove root over 1 plus cot square theta minus 1. So cot inverse cosec theta minus 1. So this is our first aim, to remove root over. Now second aim is try to express this argument in terms of cot. So cot inverse 1 by sin minus 1. So cot inverse 1 minus sin theta by sin theta. So sorry, this one is x, not 1, this is x, this is x, so this is cot theta. This one is cot theta, correct it, this is cot theta. So this is cos theta by sin theta. So 1 minus cos theta by sin theta. Sorry, this is x. Now cot inverse 2 sin square theta by 2, 2 sin theta by 2 cos theta by 2. So cot inverse tan theta by 2. Now cot inverse cot pi by 2 minus theta by 2. So if no restriction is given, we suppose argument belongs to principal value. So there is no restriction, so this is pi by 2 minus theta by 2. So pi by 2 minus half cot inverse x. So this is simplification. This is our simplification. Now cot inverse this is reduces to pi by 2 minus half cot inverse x. Now if you want to differentiate it, so y equals to pi by 2 minus half cot inverse x. So differentiation is very simple. So this is 0 half into 1 plus x square. Minus is absorbed, cot inverse x minus 1 by 1 plus x square. So minus plus. So argument is not simple. So simplify, and this is simple argument x. Then perform derivative. So this is our main aim in each problem. Now problem number 5. This is very simple. You try to solve it. Problem number 6. Y equals to sin inverse root 1 plus x minus 1 minus x by 2. There is restriction 0 less than x less than 1. So look, 1 plus x, 1 minus x, both are present. So try to recall the transformation. A plus x, A minus x, both are present. So x equals to a cos theta. So here a is 1. So x equals to cos theta. So what is theta? Theta is cos inverse x. Theta equals to cos inverse x. Then try to omit root over sine. So sine inverse 2 1 plus cos theta minus 1 minus cos theta. Sine inverse root 2 cos theta by 2 root 2 sine theta by 2. So sine inverse 1 by root 2 cos theta by 2 1 by root 2 sine theta by 2. So our main aim will be to express this argument in terms of sine. So sine inverse sine pi by 4 cos theta by 2 minus cos pi by 4 sine theta by 2. So 1 by root 2 is sine pi by 4, 1 by root 2 is cos pi by 4, because this is well known formula of sine. So sine inverse sine pi by 4 minus theta by 2. Now with the given condition, you see whether this restriction belongs to principal value. So look, 0 less than x less than 1 imply 0 less than, what is x? Cos theta less than 1. So 0 less than cos theta is 1, cos pi by 2. So 0, this is cos inverse 0 and this is cos inverse 1, and this is decreasing function. So 0 less than theta less than pi by 2. Now 0 greater than minus theta greater than minus pi by 2. So multiplying throughout by minus sine. So what we are getting, 0 greater than minus theta greater than minus pi by 2. So 0 greater than minus theta by 2 greater than minus pi by 4. Now argument is pi by 4 minus, so add pi by 4. So pi by 4 greater than pi by 4 minus theta by 2 greater than 0. That is 0 less than, writing it in reverse form. In this. So argument belongs to principal value. Argument belongs to principal value because sine inverse sine x. So this is 0 minus pi by 2 to plus pi by 2, but it is 0 to pi by 4. So belongs to principal value. So if it belongs to principal value, then this is pi by 4 minus theta by 2. So pi by 4 minus half cos inverse x. So this is our simplified value. I am saying repeatedly, if no argument is, no restriction on x is given, we suppose this argument belongs to principal value. Otherwise, you have to show it belongs to principal value. So what is simplified value? So simplified value is pi by 4 minus half cos inverse x. Then you can perform derivative also. So what is dy dx? So look, here argument is not simple, this one is big argument, but here argument is x. So half unchanged root under root over 1 minus x square. We because derivative of cos inverse x is minus x. This is derivative of, so minus adds up. So dy dx equals to 1 by root under 1 minus x. Now problem number 7 and 8. 6, 7, 8, they are of same type. So problem number 7. Y equals to cos inverse 2x minus 3 into root over 1 minus x square by root 13. So within root 1 minus x square. So transformation is x equals to cos theta or sin theta. It is cos inverse. So write theta equals to cos x equals to cos theta, theta equals to cos inverse x. Now our first step is to remove root over 2 cos theta, and this is 3, 1 minus cos square theta, sin theta by root of 13. Root of 13. Now write it in this form: cos inverse 2 by root 13 into cos theta minus 3 by root 13 into sin theta. So our main aim is to express this in terms of cos. So you know cos A minus B or A plus B, cos A cos B plus sin A sin B. So take 2 by root 13. So this equals to cos alpha, and 3 by root 13. This equals to sin alpha. So this is r cos alpha, and this is r sin alpha. So what is r square? Cos square alpha plus sin square alpha is 1. So squaring and adding. So r square bracket cos square plus sin square. So 4 by 13. Thus 9 by 13 equals to 1. So r equals to 1. And what is tan alpha? Equals to 3 by 2. 3 by 2. Alpha equals to tan inverse 3 by 2. So listen again. We are using transformation in terms of alpha and r. That is why we are finding alpha and r. Now, next step, y equals to cos inverse cos theta cos alpha minus sin theta sin alpha. R. This is also r. So cos inverse r cos theta plus alpha. So put value of r. Cos inverse, this is 1 cos theta plus tan inverse 3 by 2. So no restriction is given. So cos inverse r is 1 and theta equals to, what is theta? Tan inverse 3 by 2. So no restriction is given. So we suppose it belongs to principal value. So we are getting theta plus tan inverse 3 by 2. Theta plus tan inverse 3 by 2. So what is y? Y equals to theta plus tan inverse 3 by 2. Theta is cos inverse x plus tan inverse 3 by 2. So this is simplified form. This one is cos inverse x plus tan inverse 3 by 2. Now, if you want to perform derivative, then dy dx, derivative of cos is 1 minus x square root over 1 by 1 minus this with negative sign and not involving x and y. So this is constant. So derivative of inverse circular function. First simplify it into simplest form by using transformation. Then perform derivative. So today, through this video, we have learned how to simplify inverse circular function into simplest form, and then how to find derivative. So thank you for today.